Yikes. Cool beans. Here we go. Part B. So we're still graphing. Finish ourselves. Yay. Okay, so we're doing more of the graphing, more of the one-to-one property. We're just using this natural base. So instead of a base of like an integer or a fraction, we're going to have this lovely letter here. So natural base looks like this. You'll have this lovely, okay, yeah. So we're going to write exponentials, that's like y equals e to the x power. So e is going to be our base for today, and there is a button on your calculator to approximate the e value.
Would you put your calculator?
Yeah. So I want to say e is approximately like 2.718, if I remember correctly. And the decimal will go on forever, but it's basically an irrational number. So you can't ever write as a fraction. Decimal is non-terminating. Yeah. Yeah, it'll go on forever and ever and ever. Basically, this number comes from a compound interest formula. And now I forget how it actually like works out. But I know in compound interest it's like rate over n to nt power. And this whole piece, I think as n gets larger for whatever rate it approaches this 2.718 value. But it's not technically necessary for what we want to do, understanding where it comes from. We just know e is just approximation. Okay, so we want to sketch this guy. So I mean, it's similar to yesterday. We could describe the transformations, but with a base e, we don't necessarily need to. We just plus points and graph it. We should, however, always identify the horizontal asymptote. Remember how to find that horizontal asymptote. Yeah. Yeah, so I don't have a case, so it's just 0. So I write y equals 0, or it's going to be the x-axis, however you want to think about it. So I can draw that on my graph. So I'm not going to cross that line. Do we know, is this going to be above the x-axis or below the x-axis? It should be above because our a value is positive. And then either it's going to be like a decay model or a growth model. So let's just plug in some x values and figure out these points. So maybe just do like -1, 0, 1. The growth. See, I think it's decay because this number is less than 1. But I'm not 100% positive. Is it a rule?
I thought it was a 5.
It says,
See, I'm unsure.
Oh yeah, if
if
b is in between
0 and 1 is decay, and if b is greater than 1, it's growth. Or greater,
So technically, e is acting as a b value. So this is greater than 1, so that would make it growth. And then since this is a positive, maybe it was growth.
we never had.
Yeah, we did one where it was like a positive exponent and then a negative exponent. The positive exponent was growth, negative was decay. But we never had anything with like a number in front of the x value. So that's why it's just like, I'm not sure. 3 plot points, it'll tell us. So. Okay, so we'll have to type these in our calculator since we can't do like 2.718 to a decimal power, and then if you can, I'll be super impressed.
X. And after,
We'll do like 0.17 times -1.
oh,
Yeah, do we did.
that's 1.21832.083.
So we got for -1.
Oh, can you just type
That's
that
your
one?
total. 2.2.
For 1 or 0?
For, no, for negative 1, 4.22.
Oh,
There you drop to.
Okay.
Fine.
okay. So like right there. So there's my 3 points. I'm assuming if I plug -2, it'd get closer to this asymptote. So I'm just gonna kind of approach it all the way down. Possibly. You can always graph it on your graphing calculator and check it. Make sure it looks right. Just type the whole thing in Y equals and press graph. Okay. Graphing shouldn't be difficult, you're just kind of plotting points. As long as you know the asymptote, you're not going to cross it. Okay. Here's the next part. We have this lovely e to the x squared plus 8 power equals e to the 6x power. So we learned this lovely thing called the one-to-one property yesterday. So we're going to apply that for this example anyways. Yeah, since I have the same base, they can kind of just go away. Then I just have this equation though. How do you like to solve the quadratic? Okay, so subtract 6x. Nice. Can we factor this? Should be able to. Yep. So I can set them both equal to 0 and solve. So x is 4 or 2. Answers. I like those ones. They're easy. Okay, so last thing, we have 2 compound interest formulas. And now hopefully I remember them correctly. So the first one is if you're compounding it, I'm going to say like n times per year. So we have a formula that looks like this, and it should look familiar. And I think that's right. I should actually make sure. Give me a second. I think so. I know you did learn it in Algebra 2. I'm not sure when. Yeah, okay. And then the second formula, I like to, this one's easier to remember. Compound continuously. And I always call it PERT because it's e to the RT power. Yeah. So depending on how many times you're compounding your interest, you want to compound it as many times as possible and get more interest that way. So the goal is compound continuously. Sometimes things come up with that one. Okay, so remember these formulas. We're gonna apply it to this kid's lovely 12th birthday. Okay, so on a child's 12th birthday, a deposit of $25,000 is made in a trust fund at 8.25% interest. That would be kind of nice.
$25,000 birthday.
At 8.25%.
interest.
What kind of world is?
I don't know. It'd be a magical world.
I wish I got $25,000. 8.25% on my 12th birthday. That would be. Oh, and it's compounded quarterly.
Order. You gotta be a millionaire before that.
You'll be a millionaire like next year.
Okay, so we're using our first formula, because we're compounding quarterly, not continuously. Does anybody know what P represents in the formula? Maybe I should have said that. P is the principal, which is like the starting value. So in our case, the starting value is 25,000. And then R, I'm assuming you know is the interest rate. And then T is the time. Okay, so 1 plus. Now to rewrite the interest rate as a decimal. So 0.0825. What's my N in this case? How did you get 14?
I don't know, I was just picking 12 or 26 months.
Oh,
And that's what I picked.
that would be like the T value. N is the number of times you compound it per year. So 4, since it's quarterly. And then 4 times 14. Yeah, because there's 14 years between 12 birthday and 26 birthday. So I need to figure out what this value is. So I would probably just plug the whole thing into your calculator. And hope for the best there.
$78,423.699.
70 cents. That would be kind of nice.
So how
26 years of age, you got that much money.
Oh, monthly. Nice.
Monthly would be the same thing though, right? You're just plugging in.
And you pick up a billion.
The same formula. Monthly is changed from 4 to 12. Everything else stays the same. You get whatever number value that is. What do you get?
I just don't know. I got like 79,000. Alright.
It shouldn't be too crazy far off.
Well,
Yeah, because it's 20.
one is compounded 4 times a year, and the other one is compounded 12 times a year.
Yeah.
Why
You're
is
just taking interest more time, so you're not like putting $25,000 into your bank account every 12 months. Just trying to collect more interest.
Oh. 79,037.60.
Okay.